In these examples, we're going to find all of the critical points of the given function. Now, just to remind you, the critical points are points where the derivative either is 0 or does not exist. So here's our first one. H of x is x squared plus 9 over x squared minus 9. All right, so I'm just going to take the derivative, right? And I have to use the quotient rule, of course. So the bottom times the derivative of the top minus the top times the derivative of the bottom, all, of course, divided by the bottom function squared. So this looks like I've got 2x cubed minus 18x minus 2x cubed minus 18x. Okay, so these guys cancel. So my derivative is minus 18x over x squared plus, minus 9 squared. Okay, so you can see my critical points. So the derivative is going to be 0, right? Where the top is equal to 0. So at 0, and then it doesn't exist where the bottom is equal to 0. So I've got my x squared minus 9 squared equals 0. So that would be plus or minus 3. So those are the 3 critical points of the function. Of course, the function itself does not exist at plus or minus 3. So that's really very important to have there, because later on we're going to be making sign charts and the function may change sign there. But yeah, obviously, if I've got an asymptote, I'm not going to have a maximum or a minimum there. But nevertheless, they count as critical points. I want to make sure I have them around. Okay, so another example. There's go. Here we go. X to the negative. No, it should be x to the 1/3 times x minus 2. Okay, that's okay. So what do I have here? I want to take the derivative. Let me just write it out a little bit nicer. X to the 4/3 minus 2. Maybe I did want the x to the minus 1/3. Let's make it x to the minus 1/3. Let's see what happens there. No, actually, I didn't want that for a reason. That's right. I wanted it this way for a reason. Okay. It might not work out, though. Like, it might not work out to a nice number. We can live with it, though. The reason I wanted that is because you can see that something might be happening at 0. So the derivative here is going to be 4/3 x to the 1/3 minus 2 times 1/3 x to the negative 2/3, right? Okay, so what is this? I'm going to write it a little bit better. 4/3 x to the 1/3 minus 2 over 3 x to the 2/3. So if I make a common denominator, it's going to be 3x to the 2/3, right? So at the top, I'm going to end up with 4x minus 2, right? Because I'm going to have x to the 1/3 times x to the 2/3, it's going to be x. All right, so this is what I end up with. So what am I looking for? So I'm looking for where it's equal to 0, so that would be where the top is equal to 0 or x equals 2. And then I'm also looking where this is undefined, and we can see that that's where the bottom's going to be equal to 0 or x equals 0. Okay, so those are my 2 critical points. I do want to point out, and that's why the signs, this is the way I want the sign to be for this problem. I wanted it to be this way because you can see that this x equals 0 is a perfectly legitimate point. G of 0 has a value. It's equal to 0. So this could be a maximum or a minimum. It's a critical point. The derivative is equal, is undefined there, but the function itself is not undefined there. 0 is in the domain of this function. All right, let me see. I got maybe one more. Hey, where'd it go? Where it go? All right. All right, so f of theta is theta plus square root of 2 cosine theta. Right, I'm going to take the derivative. I'm going to get 1 plus root 2. The derivative of cosine is negative sine, so I have to be careful there. Okay, so this is defined everywhere, so I don't have any critical points that come from the derivative not existing, but I do have my critical points that come from where this is 0. So what do I have? Negative root 2 sine theta is negative 1. Sine theta is 1 over root 2. So of course that's root 2 over 2, positive. So what we're going to get is either pi over 4 or 3 pi over 4, right? The sign is positive, and we want all of the critical points, so we're going to add a 2k pi to each of those. Okay, so if it asks you for all the critical points, and it's a function like that is periodic, like sine or cosine, you do have to add the 2k pi. Or 2n pi if you prefer, whatever. Oftentimes, though, they'll only ask you for the critical points on an interval, so just be aware of that.